Anyway, it's a great pleasure to introduce Dr. I don't know how to say Hsinchun Chen. He's the McLennan Professor of Management Information Systems at the University of Arizona. He's doing some very interesting work about data mining for purposes of security. And he's going to talk to us on crack data mining and visualization. Well, you see this. And we've heard about him about 2 years ago from Gary Strong at NSF, and he was very interested in us joining this type of work. And so we tried to lure him here even into the workshop. We didn't succeed in, but at least we have succeeded in luring him here to give us a talk so we know something about this interesting topic. Dr. Chen.
Okay, thank you, Brad. I think I should have about, can you hear me in the back? My voice doesn't project very well, so I sort of have to yell. I think I should have about 1 hour to go through about 45 slides on my 45 slides of this set. And then if you find anything of interest to you, I might get into more detail about other sub-projects. But before I proceed, let me just get a little idea about the background of this audience and try to see what kind of topic I should emphasize, what kind of topic I should emphasize. How many of you are faculty in a real job? Sort of real job, okay? Researcher, okay? Students, trying to get a degree, okay? How many of you will put yourself as a computer scientist? Okay? Electrical engineer, researcher, computational linguist. Okay, I thought you are in speech and language understanding. You should have a good proportion. Human-computer interactions, interface visualization, that kind of thing. Data mining, anyone? Data text mining. I'll try to find the least number of people that I'll talk a lot about that to make sure I can trick everyone. Okay, I think I have some idea about the background now. Just by way of introduction, my undergraduate degree are mostly in management science, using math technique in the different areas of management, statistics, and so on. And then I get into information system, computer science. And my early career are more in the human-computer interaction area. But my background, I'm mostly trained in artificial intelligence. So I sort of a second generation descendant from Herbert Simon kind of school of thoughts about how to model human intelligence and so on. But unfortunately, I wrote a dissertation about information retrieval and artificial intelligence. So how to use artificial intelligence in the context of information retrieval. At that time, it's sort of considered a library science topic. At that time, information, this is not data management system. Data means Oracle and that kind of thing. It's not. But this information, this is about books, about abstracts, and so on. So people sort of classify me as library science people, but that was 1989, so 4 or 5 years before the web became a real thing. So people at that time really don't talk about text as a serious object. Well, sorry for this audience, but a lot of people just look at the structured data. So when the web started to become interesting, then my group and my research lab has done about 4 or 5 years ago work. And then we started getting into search engine digital libraries. So my background actually started in 1993 in NSF Digital Library Project. Anyone who have heard about that? Just a few, okay. So that project was going on from 94 to 98, and then that's Digital Library 1 and Digital Library 2, 99 to 2003, and then the other derivative of different kind of digital library projects. So my early life has a lot to do with digital libraries, using new text data mining, text mining, word mining concept in the context of digital library search engine application. Now this project called coupling actually started about 1997. And I was brave, and at times people call me foolish enough to talk to cops. And basically they say, well, can I use this as a technique in application that have police reports? And can you use that to help us investigate police leads and so on? So starting from 1997 till now, and we actually put a lot of effort in this research. Just by way of acknowledgement, NSF, recently we've expanded to the CIA research, working with some intelligence community. And then NIJ is Department of Justice, and COPS is in the COPS office. and then some of our research partner, Tucson Police Department, Phoenix Police Department. I'm going to use some data to illustrate a point in a few minutes, since a lot of the real testing are based on the data that are provided by the users and so on. So the title actually has a few components. This is about crime, data mining, and visualization. So many of you know data mining. You want to extract knowledge from data and using different analysis techniques. But here I'm going to focus more on crime. And I'm also going to focus on visualization. Typically, data mining people talk more about algorithm detail statistics, neural network and clustering and so on. But care less about the final output, how the user use it. So I'm going to focus a little bit more about that. And I'm going to talk about this area called intelligence and security informatics. And this is something cutting across from local law enforcement to state, to FBI, federal government. So this is domestic, and from domestic to international, like CIA, NSA. I was just in a meeting at DIA, Defense Intelligence Agency, and you just couldn't imagine the amount of hassle you go through just go into somewhere to meet someone. It took about 2 hours to check the vehicles, check the PC until you check everything and get into inside of high security clearance kind of places. But I think there's a science which is emerging called intelligence security informatics. Just like medical informatics, bioinformatics, there's a science in the process getting surfaced. And part of the reason is because, of course, after September 11, people put a lot of attention to that. At the same time, agencies like NSA or DARPA are putting a lot of emphasis on this. But sometimes they're taking a sort of a fast-track approach. Getting off the shelf package, let's do it right away, but they don't think 5 years, 10 years as a systematic problem. But there's a need of developing a science to carefully study data integration issue, mining issues, policy issue, privacy issue, and how we put it all together as an informatics science, not as just buying the software and let's do it right away, okay? And I'm going to talk about our experience in this covering projects. In the interest of time, I'm actually going to fly a little bit faster. For some of the slides that are more basic, and for some of the slides that is not as obvious, and then I will stop, I will just pause a little bit. And first, I probably can give you a pop quiz at the end of the presentation. Okay, just to make sure that you pay attention. So I'm going to talk about a general research framework, how we perceive the world, what is our paradigms of dealing with the problem that we try to address. And then I'm going to show you the data characteristics. What kind of things that you can extract to create knowledge or to mine from your data. And then I'm going to quickly go through this. These are things that we have developed between 1997 and about 2000. And Connect and Detect has been successfully tested. A lot of papers talk about it. And then it's actually also fully deployed in many different agencies. Last week, we just got deployed in Boston PD. Actually, Baltimore is in the process of looking at coupling as well. There are about 10, 15 states, and these have been reported in New York Times and Washington Post. The system was actually used to deal with the sniper investigation. That was the case in Washington, D.C., shooting people at the gas station. So that the system actually used to find a relationship. But this is something that we have done, is old news. I'm going to spend a little bit more time on this, so I'm going to fly a bit faster here. These are some of the things that get me more excited. These are the sort of cutting edge, bleeding edge, and at times, a little bit flaky. You have to find the right place to use it. So at some places it works, at some other places it doesn't work. And these will cut across things from crime visualization, agent deception detection, criminal network analysis, and so on. And when I discuss this, I'll try to put it in the context of some of the sort of speech and language understanding. And right now, I'm really just reviewing big paradigms. I won't be able to get into the depth. If you need to get more information, I'll give you a website. I have a big website that has a lot of PowerPoints, and there are 20, 30 big demos. Each demo have hundreds of thousands of records, millions of records. You can just go there and try to crash the system the best you can. So at the end, I'll give you a pointer that you can get more information. But today, I'll just try to give you a review. And let me also qualify that actually coupling is actually 1/3 of my lab. So there are about 15 people dealing with this. Another 1/3 deal with digital library search engine. And the last 1/3 use similar set of technique in medical informatics. This is genome research. This is looking at protein and interaction, creating a pathway using data and text mining. So I'm going to just review 1/3 of my research lab, but this one is very interesting, especially quite relevant to this audience. Okay, So I'm going to really go fast now, so let me talk about the framework. It's a very high-level introduction about national security, about intelligence agency. Doesn't work together, but they're needing to analyze the information from CIA to FBI, and again from international crime to domestic, from domestic to local law enforcement. Let me try to remind myself, at the end I'm also going to talk about something that we're in the process of creating, very new things in the area of terrorism research. How to analyze the content using the web as a resource to find out information and to do analysis and so on. So there's a great difficulty of analyzing large amount of data involving criminal and terrorist activities. So there are a lot of different crime types and there are different criminal activities. But I think the thing interesting is that a lot of those activities, especially more serious ones, are more highly organized. Meaning that if they're organized, there's a pattern. If this is more random crime, and this kind of data intensive processing technique won't work. You really need to have the things occurring frequently, essentially you can extract the patterns. And KDD is a project which is right now funded by NSF. There are 16 projects picked by NSF among the PIs, and these are funding go from intelligence community through CIA, and from CIA to NSF. A little bit sound like money laundering, but go to NSF, NSF go to researcher. And this is this program called Knowledge Discovery and Dissemination. And what they try to deal with is use a data mining technique or approaches to deal with the vast amount of intelligence and security information. And so let me quickly get into this research framework. And there are actually two dimensions. On one dimension, these are the crime types and security concerns from local to state to international and so on. And the other dimension are some of the techniques that can be appropriate to deal with certain crime types and security concerns. Many of you know in local law enforcement from when you get traffic tickets, which tend to be a little random, but sometimes there are people who are frequent offenders that could happen as well, to theft and fraud and so on, but this is a local level, they just deal with one particular jurisdiction. And then the crime becomes more serious when you get to gang and drug, narcotic, and then get into more violent crime with use of weapons and guns and bombings and so on. So the thing becomes nastier when you go to the extreme. So when you look at the national security level, again, traffic violation is an issue, but from sex crime to theft, and this could be identity theft, using the cybercrime, using the internet as a way of doing it, the fraud, internet frauds and so on, and these are mostly in cross different states, even cross different nations. In the case of fraud, and I'm going to talk about a piece of research in the area of deception detection. So actually, I'll try to focus 3 pieces of research today. One is in the area of deception detection, how to use people's identity information that they lie in trying to triangulate, they find out the truth using a data mining approach. And the second one is sort of a criminal network analysis. How do you find out these persons associates and find out the structure of gang network, narcotic network? Understand the topology. Is this a string? Is it a star structure? Is it flat? What are the subgroups? Who's the key members? What are messengers and so on? And how do you see that evolve over time? So that's using social network analysis technique. And then the last one I'm going to talk about will be in the area a little bit about the cybercrime authorship analysis. How do you find, based on people's writing on email and news group, can you develop something called right print? You know fingerprints, right? Fingerprint probably have very high accuracy, but people actually have a right print. When they write, there's a style. And this style are sometimes a very low-level features like the length of the sentence, uppercase, lowercase, use prepositions, and there are many, many features that you can combine. And I'll show some example of how we have done it. So then gang, narcotic become more critical, and actually like the mafia in Italy, and even in a jurisdiction of Tucson. Tucson has about 1 million people. It's about 1,500 cops. And then if you look at the gang and narcotic people, there are actually thousands of members, and especially they're close to the border. So for the drug network is actually a very big problem. And most people, they are not, those gang members, the drug members, they don't stay in one place. They typically go from Tucson to Phoenix to San Diego to Los Angeles, and then again, they're very mobile. But the data are not. I mean, the state of the technology right now is that in every agency, they have their own stovepipe system, just cross the street, they don't talk to each other. unless someone picked the phone. It sounds scary, I didn't even realize that. But the reason that the sniper investigation wasn't so successful initially was because the person was jumping around in 5 or 6 jurisdictions. Each jurisdiction has their own data. And they cannot share it all unless someone picked up the phone. Could you check that for me? No one can check it themselves. So we put our system on top of all the 5 jurisdictions, and in 5 days, everyone is talking to everyone. Okay. So criminals are mobile, data are not at this point. And that's local law enforcement. Local doesn't talk to FBI. FBI cannot talk to CIA. There's certain legal regulation. And you talk to NSA and so on. Everyone has just so far. Everyone knows bits and pieces of the entire puzzle. Actually, many of you know that eventually people found out that the car was actually Caprice, not the white truck that everyone was chasing. But when we go back to check the records, actually, the information is scattered in all 5 databases. But they are bits and pieces, they can collectively put them together to find the patterns. So the power of data is very obvious, but again, the current technology really haven't allowed the community to absorb this kind of integrations and analysis yet. So when you get into the violent crime like terrorism or hijacking, bombing, that become even more serious. And then, of course, with the internet and cybercrime become also a different class of problem that you have to deal with. So if you line them up together, actually, local law enforcement, state to domestic FBI to international, they face very similar kind of crime, some of them at the local scale. So if you want to investigate international level terrorism, they don't stay in vacuum, they stay in local. They are in San Diego, they're in Phoenix, they're in Baltimore and so on. So how do you triangulate the data such a create a big picture? So this is very important that both groups have to work together. So those are crime types. So the thing that you really want to remember is that there's a few conclusions. One is local and state, there are a lot of overlap. And the second important aspect is that when crime becomes more organized, more serious, then there's a pattern. If there's a pattern, then you can do something about it. If it's very random, you require human intuition, insight, and luck, and so on. But when there's a pattern, you can do a lot of good job using computation technique. So these are some of the computation techniques that have been talked about in the context of data mining. So now you assume you not only have your jurisdiction data, you have other jurisdiction data. You don't have to put it in one central data warehouse. It could be distributed. But let's assume that there's some way of interacting with them. And this is the thing that a lot of agencies are promoting right now, sharing information. But once you can share the information, then you have information overload problem. Just like Google, when you enter keywords, anything, you get 250,000 hits. So what good is that when you have to go through the whole thing? So you need to have some way of condensing the information. In the context of crime analysis, I think some of you know data mining, but if you use that in the context of crime intelligence application, their technique ranging from association rule mining. What I mean is that if someone do this, do they frequently do the other thing? If they buy a diaper, do they frequently buy beer? That's a very famous example actually in the supermarket. Young man, 5 o'clock at night, the wife call the young professional, the baby at home, so buy the diaper. So I go there, buy the diaper, but it's Friday night, so what do? You grab a beer next to it. So the transaction pattern is always diaper and beer. Not beer causing the diaper, but diaper causing the beer. But that's the association rule, based on how things occur. Okay? But these kind of cases happen a lot in crime. 2 guys always do something on a particular kind, a particular location. The criminal has a particular pattern. But here we're talking about 2 objects, object meaning location, people, weapon, and so on. But you can find the association. Classification and clustering. Classification try to do some prediction. If I see this set independent variable, they're going to cause this dependent variable to happen. Causal relationship. So you need independent variable and dependent variable. Clustering only have independent variables. I'm grouping a set of association rules that are very similar to each other as one class. So instead of doing a pair of objects, you're doing many pairs of objects that have similar patterns. So you try to cluster them based on similarity, so you can put items into classes of similar characteristics. These are techniques that are more well known in the data mining community because he has been using commercial world. Walmart is using that for their tracking of the inventory and so on. These are well-known techniques. These set are less well-known, less used in the data mining, conventional data mining community. Each application has a particular characteristics that you can leverage. In crime and national security application, at least these are 4 or 5 that were observed to be quite important. Social network analysis attempt to establish a network to look at the roles of individual, the flow of tangible goods and evolution of the group, and even cross-jurisdictional relationship between people, organization, and so on. So again, the criminal doesn't live in a vacuum. They need a friend, they need a vehicle, they need people they work with in a bad way, of course. But you can create a network of how they interact with each other. And then another thing interesting is that many of those intelligent information has a sequential pattern, time. They do it in a particular sequence. And sometimes time is mixed up with the location. Space and time, when did that happen is very important, because you can look at a certain crime only happened on Friday night at midnight from 10 o'clock to 2 o'clock in the morning. Okay? And again, terrorists, they may have a particular pattern of doing a particular thing. They won't do it when they're doing the praying. For those people who are Muslim, so there are certain things that are based on time. And there are actually techniques in data mining that deal with sequential patterns. String comparison try to deal with text. But text, these are things like someone trying to deceive you by giving you the wrong social security number, but off by 1 digit or 2 digits. They won't try to trick it entirely. You just get enough false information to throw you off. And on the other hand, they need to just give you a little bit such that they still remember to repeat a lie. If they give you an entirely big lie, then it's very difficult to repeat itself. And so this you have to deal with the different characters and permutation and even pronunciation. Sometimes people will use, especially in different countries like Spanish word whiskey, how to say whiskey. He's telling you the truth, sort of, but the pronunciation is the same, but the spelling is different. But that's enough to throw any computer system. When you try to do a query using that name, you will find it. And entity extraction is mostly specific. I think this audience, many of you know what entity extraction is. But typically, you will extract the important concepts from the textual documents. So these two dealing more with the textual document from police reports to intelligence reports, find out who, what, where, locations, and so on, but using the automatic technique. So when you put them together, there are two axes that we can look at. So this is the crime types that become more serious. When you become more serious, you become more organized. On this axis, you try to identify individual entity, who, what, where, just one document at a time. Then you try to do association and clustering. So when I see many documents, I can start to see those two people always occur together. And I can do clustering, these set of people always occur together, grouping. Then you can make some prediction, and you can even see it with some kind of visualization. I'm going to show a lot of pretty pictures, but in this community, you need to be able to visualize analysis result in a way that people understand. Not just using a big relational table and go there to dig it out. You have some way of allowing analysts to put in their intuition and inside knowledge into analysis process. So visualization is also equally important. So let me skip this one. Let me quickly walk through the data characteristic. And this is a test bed that we have prepared for KDD, for our researcher to experiment with. To just give you some idea about the problem that they're facing in law enforcement. So these are examples of the data, and I also want to illustrate the complexity. These Tucson Police Department, typically they have different databases, record management system, store everything about any interaction between a citizen and any complaints, any crime. The police, by their duty, they have to write a report, and a report going to record management system. So any interaction you have, any cops, they have to write a report, okay? And they type it and so on. And there are mugshots, which are more multimedia, and in this case, we can also incorporate fingerprint, but we didn't. But mugshot is very important if they're looking for criminal and they have the face, and they can compare with them right away. And gang databases, these are more specific to a particular unit, in this case, only for the gang unit. If you look at the number of documents, imagine a jurisdiction that has about 1 million people, 1,500 cops. This is typically the amount of data they have. They're pretty uniform. They're typically about this amount. So you could have 2-3 million reports. Pawn tickets, 150,000, and warrants and field report. And these are all the data in Tucson. And then in terms of object of interest to them, this is very important because when you are doing investigation, you may need to look at incident report, but most likely you want to find out, you cannot find this person, but you want to find out the associates. You want to find out investigative crew, where does the person live? So these are the number of object meaning person, property that they stole, vehicle, organization, weapon, and so on. But as you can see that there are a lot of criminals in the database, 1.3 million, and a lot of property laws and so on for jurisdiction. And actually, Tucson only has about 6 or 7 years of data. Before that, a lot of them are in the big warehouse with the folders, because they take the folders out, and of course, they just stop using any of those information entirely. But textual data are extremely compact. So the raw data is only about 7 gigabytes, but indices is quite big. We have quite a lot of indices. A lot of people do partial search, phonetic search, and so on, but this is almost double the size. If you look at an agency like Phoenix, so in my lab, we actually secure file, we have all the entire unscrubbed data of criminals, incident reports in entire state of Arizona. But in Phoenix, they don't even have a relational database. So when I talk about stovepipe, Tucson actually have Oracle database. This one is DMS Unisys system. Anyone have heard of it? Have you used it? This is not even a relational database, it's a hierarchical database. So how do you query the data and do the query? Almost nightmare. And Phoenix is about 4 to 5 times bigger than Tucson. It's 4 or 5 million people. It's still growing. And actually Phoenix is composed of about 7 or 8 jurisdictions as well. There are different subdivisions, and again, their data are not entirely shared yet. But if you look at the number of records they have 3 million reports and arrests 200,000 and citation 90,000. If you look at object of interest from property, person, vehicle, and so on, but these are all in the millions. So here, the reason I'm showing this, you also need to think about the scalability of any technique you develop. You can do a prototype that deals with hundreds of objects, 1,000 objects, but eventually you always have to deal with at least millions or tens of millions of objects. So the size is very similar, 2 times the indices. The differences between those two are, the most important one is that Phoenix actually has a lot of narrative. It means police report, someone type a report. So-and-so go there to investigate and find this guy, Big John holding a gun against the other one, and then according to the witnesses, he said this guy robbed the other guy, and the shorty actually ran away from the trap. And unfortunately, they type everything in uppercase. There's no, for those people doing anything, capitalization give a lot of clue about people's name organization, but police are trained to, they turn on the cap key, schema typing. And that is not helping your entity extractor at all. So your accuracy just, they use a lot of acronyms and things I understand, but so you really almost need to customize it. And so narrative, I think, is the most interesting one. And in this research, we actually scrub the data, and so the data actually have been processed, have been made available to people, but no one is using it yet. But not like everyone can access this. You have to go through the NSA, KDD, partnership, and then get the agreement, because even though they're all scrubbed, but if you do a very careful reverse engineering, you can find a certain crime in a particular apartment building, and you can actually guess. For people who really want to take into these data sets. So security privacy is a huge, huge concern. But these are real life data, and it's a security issue. There are liberosity issues that you have to deal with. But right now, we're trying to make it as consistent as possible, even when you scrub it. The same person, when you scrub into another name, they will be scrubbed exactly the same in different databases. So you can sort of still find their linkage and their relationship. So this data set is available right now. And just show, again, the complexity of the problem. So this is one example of an object called person. Person has a real name, date of birth, race, gender, minimum date of birth, maximum date of birth. They give you a given date of birth. Height, weight, minimum, maximum. And then you can look at the race type, you can look at the gender. And some of the gender, they change. Okay? People do change. These are weird people. So a lot of things that may change in the middle, but this is just describing a person, and this is one big table, and then the other 3 smaller tables. So for agency like Tucson, they have about 217 tables, okay, about 1,000 fields, 1,000 attributes that you have to deal with. And these are from different databases, and this is now in common. So if you go to Baltimore, PD, if you go to Washington, D.C., that's the object you have to deal with, and that's the attribute that you have to deal with. But right now in security community, law enforcement community, they try to create XML standards, so that everyone is talking about a similar kind of thing. So there's a standard of interoperability effort going on, but the thing that is still difficult is that you could create as good as a standard as you like, but then everyone has all a legacy system, right? no one is rich enough to solve it. And typically, this kind of recommendation system, for agency like Baltimore, it will be we're talking about $10 to $50 million to upgrade the entire recommendation system. No one has that kind of money, unless you get lucky or someone get lottery or something. So they still have to rely on the old infrastructure, but create a mapping from the old schema into the new schema. That's a major effort I do. And this is not technical work, it's all logical mapping. My three fields together equal to your field. When you use that name, it really means my name. So to create a mapping, that's a tremendous amount of effort. And I give you an example of a sniper investigation. But in that case, they actually share only a limited amount of data. So out of 1,000 fields, they may be sharing 75 or 100, and that makes the life much easier. So you can get away with something if you don't want to share all the information. Okay? And once you put them in a standard format, anyone can access from any ODBC databases. Okay? So you know what kind of data we're talking about. Let me quickly review two systems that have been developed. Again, this is a coupling progression I just talked about regarding initially research was done NSF and then NRJ, Department of Justice pick it up, law enforcement, and then digital government initially pick it up again. Then get into CIA, and right now, some of the new activity get into the Department of Homeland Security. So I'm not recording that. But some of the research right now is going to DHS. And these are things that take, it's sort of a progression of how companies get developed and get recognized over time. The most recent one in Boston Globe, because Boston actually implemented that. And the one on New York Times, that's somewhere around, at the New York Times, that's for the sniper investigation. But early on, there are some prototypes that have been developed over different times. So if you go in chronological reverse order, you can go all the way back to about 1997 or 98. Okay. So let me now to talk about that. So Connect is the first system that we developed. What it does is to create a software module in the middle that any system can migrate in the XML format, simply put. Okay? And so there's a set of systems, there's a set of programs sit on top of that system, looking at the changes you have made and keep on piping the information to a new data warehouse. Okay? But we've done 3 or 4 years research, it's so quick, like I give you an example, you can do it in 5 days. They're pretty small. Montgomery County is not a big agency, only about 130,000 people. Really small agency, data is smaller, so you can do that very quickly. But generically, Copy Connect allow you to use XML representation to data migration, both batch and incremental. There are new cases coming up. Database independent, web infrastructure. So really using the standard 3T architecture on database server, web server, browser. And there are a lot of powerful search tools. When you see the 2 times indices that I show you, we actually create almost every single indices you can think of for the field that you're searching. So you can do a phonetic search, you can do a wildcard search, you can do a license plate number of, I see the car running by and I think I see S in the first character, but there's something with a T in between. So you can S star, T star, and you can just do the search on that. And the same thing you can do phonetic, the informant told me that this guy is by the name of Christie. Christie, how do you spell it? So you just type in something sound like Christie, and then the system will find the message for you. So you need to do a lot of things for your customer users, because they are really, their technology acceptance level is typically very low. I mean, they're not trained in IT, so you have to make things as easy as possible. So the graphic interface and so on. So this one has been well reported. Now, copy detect is a bit different, and we start getting to data mining now, since I stayed about 30 minutes. Connect is about database research, interoperability. Enter keywords, what you get is a case report, a document, just like a search engine. Okay, if you go to Google, you type a keyword, you get a page, exactly the same. But this is going beyond Google now. So somebody calls it even super Google for cars. When you enter a term, you don't come up with a document, you get more terms. And what does it mean? I'm looking for a bad guy, but I couldn't find him. So what do? I find his or her associates. Where does he typically hang out and location and vehicle? So in this particular detect system, they call detect, it's used for detective. That's what detectives do. They don't just look at the cases, they look for clues. So when they enter a person, the system can tell you what's the most likely location this guy is going to show up. What are incidents involve vehicles and other persons as well. So we're trying to extract another level of abstraction such that you can look for similar things or similar patterns. Google doesn't even do that, even though it's very simple to do. So can you imagine Google allowing you to enter keywords and it suggests, Other things of potential interest to you, when you type in yellow submarine, the system may suggest you other Beatles song. Because if you look at the collection, that may be the kind of thing that are related somehow in albums and so on. So detect turned out to be extremely powerful, almost a killer app for this application. Initially, we showed the connect, and they say, yeah, that's fine, we can relate to that. I recommend to say, sort of do that. Primary interface, but you enter keyword, you get a document. But our system do not do this. The system cannot suggest me what other people to talk to, or use many pieces of information to triangulate them. So this one is really nothing more than a simple association rule. If I see this guy, how frequently do I see the other guy? But I'm talking about the entire 2 or 3 million people organization. Every single, you can think about big metrics. Every single person, location and so on, and do a big computation of their association. Weighted association. The more times they co-occur, the higher the frequency, the more important it will be shown. Association rule, still using XML, you can do incremental update, because when new cases come in, then you will be, there could be some new criminals. There could be all criminals that now you have updated frequency now, because they occur not one more time. Okay? And you have to do a lot of interface and so on. So this one actually, when we do the system, we have to reverse order. We get this one off the street first, and then get back to connect. So the tag actually was used first. And they were using that to book a lot of criminals. We just stop counting the success story, because in the past, a complex case may take 2 or 3 weeks to solve. But in this business, anything beyond 24 hours, I think, become very, the time urgency become very critical, that anything beyond 24 hours, the information or the clue become dated. The criminal may vanish, or the crime scene, things will deteriorate. So there are a lot of things you have to do fast. And using this file system, you can reduce from 2 days to about 2 to 20 minutes. You don't have to go through all the cases now. You don't have to fan out to go from one person to all the cases, this person involved, and look at every single case involved. One criminal, a productive one, you get hundreds of cases, look at each case, then you can find more criminal, and there are hundreds of cases. When you fan out, you do not converge back. But this is a heavy convert. Okay? So this is a simple, this is just a quick screen down, so you can search for person, location, vehicle, and you can, any of the places you can do partial search, and once you find it, you list it there, and I can say I want to find a person by the name of Dave, but I don't know exactly it's David or Davidson or whatever. The guy got away with 2-door green vehicle, okay, and I can look for any associates of his. There's actually one person who have been dealing with Damien, dealing with both this scenario 1 and 2, this incident that both of them together. And then this incident actually had another person called Davis Whitehead, which could be this person that is really what they're looking for. But this is actually start with the strongest association, then use that to give you more clue about what's the person that is most likely to the person you're looking for. And then this is actually sort of show the part integration. This part is a regular management system. This part actually comes from the workshops. So you don't have to go to different databases. And then this is just a newer interface, 2.0, 2.5. Right now it's about 3.1 now. So again, yeah, you can even search aliases, you can search a date of birth, you can search description, almost anything go fields that you want to search, you can do it. Okay. So this one has been deployed in probably 10, 12 different states and agencies now, and some of the bigger ones that are in the process of under deployment or recent deployment is Boston one, and Baltimore has a big discussion going on now. But now another big one is that we're doing in Southern California, the entire Southern California. Mostly San Diego, there are about 50 agencies all linking together. But that 50 agencies are linking to the entire state of Arizona. So you're seeing the southwestern state, they're all linking to this particular system in the project right now. Okay. All right, so let me start getting into something a little bit more flaky. Okay. These are things that we don't know whether it actually works for real life or not, but it's quite promising, and it looks cute, and looks colorful, and we got the comments. And typically the way we do research is that NSF gives us money to do basic research, and PhD students work on algorithm, they work on the statistic behind it, the framework and so on, and they create something very generic. And then research scientists and master students try to put it into application, but typically then they are not funded by NSF. and they are funded by NRJ, Department of Justice, Department of Homeland Security, CI, and so on. And then when they do really, really good job, then we move it to the agency, then they cover their own money to buy. And they apply through different grants or whatever. So Tucson Police Department, Phoenix Police Department, Boston PD, then actually buy the system. Okay. So this is going to cut across quite a few areas, but I'll just give you a flavor of what we try to do. Here, we'll emphasize two things, data mining and visualization. The first thing I want to review is in areas of network analysis. And network analysis, you can think about a terrorist network, you can think about gang network. A lot of people have a certain relationship. Typically, in this community, the first generation type use a manual approach. Second generation, the system do a better job of mapping that into a Windows kind of display, graphic-based. The thing that we're working on is sort of a more third generation type, use a lot of social network analysis, automated social network analysis, not human analysis, but trying to condense the complexity of information. So I'm not talking about 20, 30 people and their network. Typically, sociologists does that. I'm talking about 20,000 people. How to show 20,000 in the map, and how to break into subgroups, and how to look at a subgroup and see their relationship, and so on. So this is all way of doing things. You get many police officer, intelligence analysts, they will do that. On this axis, they put on people's name or investigate crew, and then in the same name, and then they put a mark. If I see them interacting together in a telephone conversation, in someone spotting them in a cafe drinking coffee together, then I put it down. So you draw that diagram, then you manually get a tool, and then just draw that yourself. Very cumbersome process. These are the second generation kind of tool, and mostly used in intelligence community, law enforcement, and so on. But these are typically two-level interaction, direct neighbors, direct associations. So you could have all the objects here, and if they have a relationship, they are linking together, or the object with their neighbors, and the system somehow try to display it visually. And many of them will use, try to use sort of a circle metaphor or tree metaphor, so that it's easy to manage. But when you get beyond hundreds, then it becomes almost impossible to manage. You just use your score bar. But analysis burden is entirely on you. The system doesn't have to reduce any complexity at all. You use your eyes to find, oh, this is important, but this becomes very visual driven. This is something that we have done the past 2 years. One is based on hyperbolic tree, very similar to the second generation tool you have seen. So this is still considered second generation. This tool is called, this is a network visualizer, but use a spring metaphor. What I mean is that initially you have person, locations, and vehicle and so on. They're somehow related, so the network is very messy. Now, we put a spring metaphor in there such that if the two persons have a strong association, then like a spring, they're very tight. They're going to pull each other close to each other. Okay. If two persons are loosely relevant, then it's a spring that is not as tight, so they lose it. But collectively, you have a lot of spring, right? And one pulling the other, and the other one trying to push it away, and then systems sort of wiggle and eventually they stabilize. And when they stabilize, you can see the structure, like this guy connecting to that, and that guy to that guy, and there's another sub-network of these people. The system actually flows around, and the energy, the global energy, stabilizes. But again, second generation. All it does is to try to give you a better visualization and put it on the computer screen. That's all it does. The third generation tried to deal with more analysis, and what we try to do is to look at the overall network pattern, identify the subgroup. Within the subgroup, the system will tell you who is the most important person, what the less important, and so on. What are people doing social network analysis here? Okay, so I can say anything I want. Okay. But this is an example, again, criminal network. This is the terrorists who are involved in hijacking September 11th, the tragedy. As you can see that this is actually all using open source information, eventually drawn by analysts. But you can see that they are sort of some network, right? It's a group of people. The thickness represents their degree of belief in the evidence. How trustworthy is the evidence?
When you say open source, you mean that
news articles and
yeah, but okay, all right.
Okay,
People
after the fact.
were after the fact,
After
and
the fact,
people were
exactly.
investigating. And
That's right, and then they put a story together.
I was there,
Exactly,
stuff like
exactly. Yeah, after the fact, maybe it's before the fact, and that's wonderful, but they couldn't do that, you know. But even after the fact, to draw a diagram like this, to find out that, again, there are people in that airplane and people in the American airplane, but then you see the pockets of interactions. And now there's some network, and there are some people who are key persons that you really need to monitor more closely. And some people, this may not be a central person, but maybe a gatekeeper between two groups, or messenger, so to speak. To draw a diagram like this typically takes months. Get investigative clue and do the uncover chart and then put a diagrams on it. I think the sun network visually and so on. But the network will grow huge, right? A CAD network is not 30 people. There are a lot of people who are related to this. Okay. So we use a set of statistical technique, but basically what it does is that concept space is association rules, trying to find every two person that get mentioned in your records and create a frequency. We also use some domain knowledge. If they're over a particular number of times, then it's likely that we're very sure that they know each other. So with that, you have a certain network. Hierarchical clustering, and we might just review the data mine on clustering. What you try to do is you have a big network, but then there are certain networks, some networks are very tight, just like the one I show you, with their all strong association with every single pair. So you try to cluster them. But you don't cluster at one time. So you could have tens of hundreds of thousands of objects. So you can big group, in the big group, you have smaller groups, even smaller groups. So you can go deeper and deeper. Centrality measure typically used in sociology, in social network analysis, meaning that who is the most important person connecting to other people? Or who is most important in terms of the shortest path connecting different members together? Shortest path is a very important concept. Long path is not relevant, but shortest path indicates you are the gatekeeper. And block modeling also allows you to reduce the complexity. And I can look at highest level of everyone, how they're linked to each other with all the details. I can reduce the complexity and say, if I try to make it more high level, what does it mean? If I try to even make it more high level, what does it mean? And yes, there's another thing. For those of you who deal with statistics, multi-dimensional scaling, try to put things on the map based on their closeness. If they're closer to each other, so there can be some things similar to a spring algorithm. If they're related, they somehow will be closer. If they're not related, they'll be projected further away on the space. So this one gives you visualization. Some then give you centrality measure. Some they give you the hierarchical clustering. And then we use real data set. So these are actually incident reports about narcotics, about gangs. So gang from 1995 and narcotic from 2000. Two data sets, initially a small one, narcotic 60 individual, gang 24 individual. We didn't say like that. We actually like the gang unit supervisor, they pick. I think that they know. And we actually have created knowledge that can be mapped into their perception of the domain that they can explain our results. So we let them choose. And then when you start to do the analysis, then narcotic, even though this number individual, then you're actually going to, if you look at all the cases, it's actually quite big. If you look at the data set narcotic, there are 12,000 people. When we do all the analysis, there are this number of sub-networks. Each sub-network can range from a small one to the biggest one has 102 members. There are different types in between. So these two are one of the mid-sized network. So let me show you some example here. All the name has been scrubbed, so it's not a real name, but it doesn't matter to you. So imagine there's 64 members and these are all people's names. And after you go through the concept space, co-occurrence, clustering, and so on, the system bank, you just put it on the map. Okay, and this typically will take seconds. Okay, on a regular PC. And again, the proximity has important because we use NDS. So if they're closer to each other, it means they're more related. So it's trying to create the effect that a subgroup can form. Remember, when you see the terrorist network, a subgroup, they're closer to each other, so create that effect. But still, it's sort of difficult to view, so we can actually reduce the complexity level by slicing the scale. And this is mostly based on hierarchical clustering and block modeling. So in this particular case, I can reduce it further into a subnetwork. So notice I slide the bar. And then in this case, they're actually circle. Circle represents proportionally to the subgroup size. There's a bigger group, there's a bigger circle, small group, smaller circle. When you double click on this one, you see, I click on this one, you see the subnetwork of this group. They actually not just one map, there's another map that you can see, but they also show who's the leader, who's the gatekeeper, who's the outlier. These are three major measures used in social network analysis. Leader means, a lot of people all point to you. Gatekeeper is between major group, there's someone controlling key information. Sometimes it's in person. Okay. Outlier are people just floating around. Okay. So you can reduce the complexity. So now you can identify the subgroup. Now this is an example of a gang network, similar things. So there's a big group here, there's a smaller group, the leader. So each group is labeled by the leader. Okay? And I can click on them and so on. Now, not only you can identify individual members' role in the subgroup, you can identify the typology of your network. If you look at the narcotic actually is mostly like a string. And when we talk to the narcotic analysts and so on, they say, yeah, it makes sense because it's actually a very process-driven operation or process-driven enterprise. You have sort of a supplier, the major producers, a wholesaler go to retailer go to distributor and so on. So there's actually a chain, and each of them has some key person that link together. So from an analysis standpoint, these are the persons that you want to monitor. But that's typically for narcotic network. But gang is very centralized, under tight control. But this is a gang network, but pretty much you need to wipe out this guy, and then this gang will collapse for a few months until the new leader surfaces. Okay. But typically you can break down the network very easily. There's people's hypothesis that the terrorist network is not like any of those two. Actually flat, almost like the one we saw. There are many small pockets. There's some gatekeeper connecting them together. You can disrupt part of the network, but they can quickly get reconstructed. But we don't have real data to show it, but this we have real data to show you how the gang and how they actually behave. And we just try to do more validation. So this is one example. Once we do the analysis and so on, then we show the data to the investigator and to the gang unit supervisor and so on. Yeah, this is a white gang doing a lot of murders and shooting, so they're like guns. And this is a group that's here, crack cocaine, but there are two different groups. Okay? But the thickness represents their number of detections. So there's a troopy group, and there's a black gang over there that a little bit further away. But so this is all consistent with the sergeant actually had about 15 years of experience dealing with this set of people. So you pretty much know everyone in that group. And then when you click on each subgroup, like I said, that this is the overall pattern. When you click on this group, you see another network. This is that sub-network within this network. And this is this sub-network within this network. And when you see that, yeah, it makes sense because number 173 and number 211 have been friends. They grow up together in the slum and they work on cases together, and each of them create their own gang. And this is an example of narcotic network of, this is a person who is actually doing distribution. But again, we cannot make up the story, but the detective, when they look at that, and they can tell you why certain thing, that pattern, why the pattern was created the way it is. Okay, so that's on social network analysis. I ought to set a slide to talk about evolution. How do you track a group over time? Because they'll start with something, start with nothing, or most individual, they go from outside outlier, meaning that they're junior member becomes senior member. You're going to track individual person how their career progress over time. Almost like a tenure system, assistant professor, associate professor, and so on. So you can track that, and you can also recognize the individual group. How they grow over time, linking with other groups, and what are the closest groups that they work with. Which year do they have a significant activity and so on. So you can actually study that dynamic very clearly by looking at their past history. Just in the incident report, but you can do the same thing for intelligence report as well. Okay. We are also doing things on cross-jurisdictional analysis. Not surprising, like I said, criminals are very mobile. So we compare Tucson and Phoenix data, they're about 5% of the gang and narcotic members, they overlap. If you know who are the key persons linking to each other. Okay. And now we're trying to create a link from Phoenix into San Diego. Okay. This is part initiative that is sort of funded from the Department of Homeland Security. We want to look at patterns of crime and try to see whether you can identify key members and key groups. So that one is more social network analysis and visualization. This one has no aggregate entirely on visualization. And I'm unable to show you a demo, but let me just quickly go through that. The idea is that in intelligent analysis, time and location are very important, where and when. And this tool connects 3 different interfaces in one place and integrate and synchronize them together. So you can retrieve a set of criminal cases. So you're looking for a particular set of crime that happened from this time to this time, that's from 1999 to 2003, and then you're looking for all the vehicle that this license plate number that some person has seen. So you get all the cases, right? These are individual cases, but in each case, remember, incident report has a record of where the crime occurred, when did it occur. So with that, you can map the crime into a GIS display. So this is standard kind of S3, ESI kind of display, because every single location, S3 has a mapping file into the actual location of the map. Now this one is actually the timeline from 1997, January, February, and so on. This is a sort of visualization slider. It's a time selector, so I can reduce the time to this time, or I can move it around. I can make it more recent. I can push it back, and then this will reflect on all 3 of them. This one is a periodic pattern tool. A crime occurs at particular periodic junctions, meaning that this is from the first day to the 31st day of the month, or it could be particular hours of the day, particular day of the week. So in this case, you can find that for some reason this set of crime occur a lot on the 24th. Okay, so the guy will get out of the job and he can only do his bad things 1 day a week, one day a month. So you go out and go and come back. So there's a pattern that you can find. And so you can analyze the crime, you can slice the data any way you want, but visually you're doing the investigation yourself by looking at periodic pattern locations and so on. And you can bring each interface to the center of your attention. So I can just look at the set of crime, a subset of the thing I look at, and then this one will be reduced, this one will be reduced based on whatever things that you select. And again, I can look at a periodic pattern and as a center of attention and then put things to the background for the other 2 interfaces. So this one is really just a very cool interface job, but the interesting thing about this is it can be applied to any system. It's actually, we're developing as an open source visualization tool called STV, Spatial Temporal Visualization, so you can attach to any data set that time and space. So we're actually going to put that for other web searching example that have more specific kind of location. And then you can also review pages if you wish, or intelligent reports and so on using time and space. Deception detection, since I'm running out of time, deception detection, let me just briefly describe what we try to do. The approach and the results. I'm going to skip very quickly now. Criminals try to deceive you, but they don't deceive you 100%. If they deceive you 100%, you're at a loss. But I don't want to say they're trained, but they have a habit of behavior. And they give you just a little bit like their birth is January 1st, 1976 instead of March 3rd. You may give you different variations, and it's not entirely lie, but they didn't tell you the entire truth. Okay? And of course, when any of them do this, then your computer system cannot handle that if you don't have a good fuzzy search or intelligence to it. So we have, and how do you, I'll just explain how we typically do the research. So we have to sit down, talk to the researchers, talk to the domain scientists, and we actually had one detective, a veteran detective from the Tucson Police Department that was assigned to our project for the past 6 years. We pay him, and NSA funding support him. And go to our lab, talk to us, and a brainstorming session. And deception is a big problem, a very unique problem in data mining. And as a researcher, I'm looking for a unique problem that other people have not dealt with. Anything that other people have done with, I typically try to shy away. But in commercial data mining, you don't have about deception. Your customer really do not intentionally try to deceive you, but not as much anyway. But here, criminal try. Okay? But they also notice that there's a pattern. If there's a pattern, we can do something about it. So based on that observation, then we actually get several hundred records from the police reports, and then get a detective to tell us which set of records are really, when they put in their time analysis, which set of records are really the same set. Even though they try to say, I'm this last name and with that locations and that social security number, when they have enough information to triangulate, they can create a big picture. But typically, their deceptions are in the 4 types. They give a wrong name, residency location, ID, social security number, and so on, date of birth. These are some of the most main identifiers. The name deception are things like partially deceived name. The complete deceived name is actually less. Changing middle initial, using abbreviation, similar pronunciation. So you can actually slide, I still use that name. Also partially missing names, name change, and so on. So there's some examples. Then you look at the percentage. So their false name, 62%, only the middle initial is changed 62%, and so on. So actually look at real data, we get an idea about what kind of patterns of changes that they've done. And the same thing, date of birth and so on. So in most cases, criminals only make minor changes in date of birth and social security number. This is a number that they always get checked on, so they have to sort of give a convincing story that they can remember instead of every time give the wrong. They should consistently give the wrong information. Okay. Now, based on that, we look at different classes of algorithm, and basically there are 2 classes that seem to fit the purpose of what we're trying to do. One class is in phonetic. Remember, they are the same sound, that kind of thing. And the other class is sort of spelling variation, and this is typically a spelling string compared to like a graph algorithm. So you're looking at added distance. 2 words how far apart that you can change it in order to correct it to another words. But that's based on strings. And we eventually decided using a program from University of Arizona developed by Udi member called AGRAPH. To spare the detail, but then we combine both things together, both AGRAPH and SoundX together, and then look at the 4 fields and their simple weighting. And then we do some training using 80 cases, do more training, and then let's see. It's using 80 cases, and then this is doing the testing. Recharge. So we basically find a threshold where the threshold point A, then you can get a highest accuracy. Threshold false negative is as small as possible. But again, I need to qualify that this is for the sample data set of still relatively small, but you can get a 97% accuracy when you have enough data to play with. And recently, so this one is actually forthcoming from Communication ACM in the next month or 2. And the major extension that we're doing for this set of research, which is in the process of getting published, is first deal with missing values. Not all records have all the complete 4 fields. Actually, 25 to 26% of data, there are certain fields missing. Okay. And the second thing is scalability. As you can see, I'm doing a similarity computation that's a very complex, very computation extensive process. These are those kind of records. But remember, I have 3 million records I have to deal with. Okay. So I actually develop a window slicing algorithm that will allow you to go through all the records and by a small window size. And you lose a little bit in accuracy, 5–10%, not more than that. But you can finish 2–3 million records in a matter of 1 afternoon. You can run through the whole thing. Okay? So that's just a quick summary of this deception work. Deception detection work. So accuracy always between 90 to 95% range. I'm going to skip agent work. This one is about alerting, about collaboration. This one is actually in the process of getting used by police officers in Tucson now. The idea is that in a search engine scenario, you have to go to the machine, you type it, and then the system gives you information. That's so busy. They should go out and bust the criminals. So instead, they create a profile of searches, okay, and they walk away. And information get updated. I'm looking for this person now. Information arrive. So the system will alert you through a cell phone pager, and so on. So it becomes a push mechanism. Push is quite obviously useful in a web scenario. At the same time, you accomplish the second task, which is collaboration. I'm looking for this particular guy, this particular vehicle. Because someone else doing similar searches, the system hook you up together and say, so-and-so is doing the same thing, talk to you. Okay, so accomplish 2 things, alert and collaboration. So this is an example using web alert, using email alert, and using cell phone and pager and so on. So again, in NSF research, we did all the prototype and user studies, and then NIJ picked it up, put it on $500,000, and then finally it's doing it in Tucson. When Tucson is doing successfully, then basically any other agency can duplicate the same model. But that's the case with Connected Tech. And this is called Agent. Basically, I think it's about a month away for Tucson to fully use that, and probably a year away from other agencies to adopt this. And then, this is what researchers, we always do user study and questionnaires and focus group and the whole 9 yards. So not just ad hoc research. In order to get published, we need a user study, so simply put. Let me quickly go through this cybercrime data, and then I'm going to show the terrorism information, so I'll try to end in 5, no more than 10 minutes. Okay. This one is in cybercrime, authorship identification. Identify right print, not fingerprint. Only why do we have a pattern? Okay. And basically, this can be used for cybercrime, this can be used for email and fraud and so on. So let me skip a few slides. So authorship analysis. Okay. So we look at email messages, we look at newsgroup, and we actually also look at multilingual. So I'm going to get into multilingual a little bit. In this particular experiment, we deal with both English email messages and also Chinese. Okay. And we try to demonstrate the same framework actually can be applied to the different languages. And then we get into a lot of literature survey trying to see how people deal with this problem. There are actually 3 types of marker. One is called style markers. When you write what's average sentence length, total number of characters, total number of punctuations, prepositions, what are typical kind of words, how much you use that, but there are 200 features that we talk about by different literature. But these are very low level, these are style marker, what they call style marker. Structural one, they imply that has a greeting, has a salutation, position of a reply text. People has a habit, when I reply, I do a dash dash HC. You don't have to, you can ignore the HC, but you know, dash dash, and that's very next side, and I put it typically on the left side, some people put it on the right side. So there's structured information. And these are more content-specific ones, I'm selling this and buying this and so on, and that's more content-specific feature. So what we try to find out is that these kind of things are more generic, right? Very content-independent. Are they good enough to develop a print? And we know for sure that it's not like fingerprint, not like human's iris. I mean, but if that becomes part of the information you can use and look at other data, you can do a good triangulation and to develop investigative leads, you still have to verify. But at least this is a piece of information that in the past has been ignored. And I'm actually reporting some earlier research. We use a support vector machine. This is a more powerful classification technique that we developed. Neural network support vector machine is considered more powerful one. But basically, in this group, you can get to almost 85, 86% using style marker alone. Okay. On a structure marker, you get to 91, 95%. Content marker actually give you just a little bit more. Okay. In some subject area, you don't have that at all. I didn't show the Chinese one. Very similar results. But the Chinese one, of course, we have to change. Style marker is more similar, but the structure marker, we actually have to do some changes. And the content marker, of course, the entire new sets. But you can get to about 80, 85% again on style marker, and then you can get about 7% to 10% using structure markers, and then content marker really isn't as important. So this is the URL that you can get more information. I'm not going to end my talk yet. Just give me 5 minutes. I'll show you a terrorism one that is quite interesting that we're in the process of building. Extremely new one, so this is sort of leading edge. But if you connect to my website with Coupling, you can see everything about Coupling. Before that, you can see my whole lab, meaning from Coupling to medical informatics. And the thing interesting about my group is that we typically, we have of course a bunch of reports and papers and so on, but we put demos, large demos. So you can go to a website and then there are 2 million records behind it that you can search. You can do, we actually created one of the biggest, what we call medical thesaurus, automatically created one. But that one we claim to be the biggest thesaurus anyone has created. Nothing more than association with medical terms. But that one is 48 million medical terms. Not words, but terms. Breast cancer, bone marrow transplantations, and this is actually extract replaces. And that research we actually used the Johns Hopkins, the Boolean part speech tagger, and then use grammatic rule to create a phraser, and then with the phraser you do a concurrence, do the weighting, or we do it for the entire 10 million, then 9. And with that, you can find all the associations. So there are examples like that you can play along with. By all means, please connect to the website. The last set of quick slide I'm going to go through is this is the new things on my mind, so I sort of want to show a little bit of what we're trying to do. Have you heard of a word called dark web? The web has the good guys and the bad guys. The web is a generic tool, and it could be used by terrorism group, could be used by extreme groups, and so on. So this is research about the dark side of the web. But this is in progress. This is actually partially funded by NSF-CI research. So, and actually, I'm going to give an entire talk about dark web next week at San Diego. We will talk about how dark web can be created. But this is an application that can use a lot of linguistic technique as well. So very quickly goes what we're trying to do. Internet has become a platform to do good things and bad things, and many, especially extreme groups, are using web as a way to promote their idea. Not just web pages. News group, bulletin boards, and all sorts of things that they can use. So the dark web is the terminus side of web, which is used by terrorists and other extreme groups. And so here, so terrorism is the definition, and we actually look at terrorism research, international terrorism, and terrorist group. By the way, this is totally non-classified information. Everything I talk about here, you can actually do the same thing on the web. This is all open source information. Okay, but of course, I won't create a dark web and send it to Jihad and say, use me. I won't do that. But this will be used by a limited set of researchers if they want to use this collection. But the definition is based on a State Department's definition of the terrorist group, and they have a long list of what people consider terrorism group. But if you look at the dark web, there are search engine results. There are bulletin boards that have a lot of different postings and so on. Internet Archive, for those people, anyone know Internet Archive, Brewster? He basically archived the net. The net evolved, changed over time, but here's an archive of the history of the net. But that's very important because I want to know how those groups evolve over time, how they grow, how they link into the different subset of the society. So this becomes very important historical resources, just like the criminal network I show you all the time, the same thing. So there are some resources, good resources out there, but there are a lot of noise. So there are different problems about information overload and so on. So this one we try to get an understanding of the web as they used by terrorists and extreme group. Use the best methodology to discover links between groups and individuals. Again, social network analysis became very important. But there's a central KKK group, there are other regional group from Baltimore to Louisiana, they're scattered everywhere. And then there are their own individual members. And there are other people who believe in white supremacists and so on. Ideology they are same, but then they believe in other things. But they are all somewhat related and they are pointing to each other. It's a web, kind of tight link, but linked in a very hidden fashion. You have to take it out. Okay. So how do we take it out? So what we try to do is, the first to create a portal about information about terrorists and terrorism. These are secondary research. What people talk about terrorism. How do you define them? How do you analyze them? So these are research report, papers. Okay? But then the second classes and third classes, they are really what they say about themselves and how they are linking to themselves, domestic and also international. So we start to look for information about terrorism. So I have a researcher that we recruited who was an analyst from CIA, and her dissertation is entitled Terrorism Research. We're using qualitative research. She doesn't have any of those tools, but she has all the domain knowledge. So the scope is you can gather the information, like Anti-Defamation League has a lot of information about the people that they try to avoid, research, individual website, news databases, and then commercial license databases. Actually, we did a search on some of the IEEE databases using terrorism, and we come up with thousands of hits. I could imagine electric engineering about terrorism. There are things that actually have been talked about historically. So these are some few examples. State Department, there's a Patents of Global Terrorism thing, Terrorism Research Center, there's some terrorism project, there are Memorial Institute of Prevention of Terrorism. So there are some big research groups, there are some databases available, particularly they're smaller, but much high quality one. And then there are things about the group themselves. So for example, if you go to that website, AmericanKnives.com, and then they have a lot of links to other affiliate groups. And then if you do a search of KKK on the search engine, okay, there's a long list. And then when you do a backlink, those of you who have done search on search engine, Alta Vista and Google has a backlink mechanism. So I can say who points to them. This is the important who point they point to. Okay, so we do both outlink and inlink. So very quickly you can see a universe of people who point to each other, and you don't just one link away when you keep going down and going backwards. You're getting a very interesting set of people. And again, like Animal Liberation Front, I actually didn't know that they're considered a terrorism group, but they are. So there are some previous incidents that actually bomb people. It's all, if it happened a couple times, then the State Department said, you're a terrorist. But this is a domestic group. So even for this kind of group, 200 results through backlinking, news portal, personal pages, and so on. So there are a lot of information out there about these kind of activities. And this is about international one, Palestinian Islamic Jihad, but of course, the biggest problem is language. Okay. So this one we're thinking about doing some like Babelfish kind of quick and dirty translation. Just get a gist of what you try to do. But you still want to rely on the link and so on to identify the linkage. And this one is in Japanese, ON. This is the one that do the nerve gas into the Tokyo subway station. And this group actually has a lot of sympathizers in all the places in Russia. The Russia official website is ON. But again, we spend 20-30 hours study, so people study each group. Well, we don't want to do it manually, but we study the method to collect information. But there's a consistent method of doing search engine, backlink, news group, the Yahoo profile. When you triangulate together, you can actually create a picture. There are a lot of noise, but you have to figure them out by triangulating all the information together. So we have a group, mission, geographic location, branches, crew members' name, in-link, out-link, history of major incidents, and so on. So even with, we probably put about a year of time to work on this now, we start to converge. And what we try to do is to use a set of automated technique, from artificial intelligence to social network, which I showed you some example already. We've done a lot of spidering work, so we can do spider of their major website to collect all the pages ourselves. We can do meta searches, meaning connect to search engines, get everything, all the search engines, and get everything about KKK, for example, and then triangulate the information. Each search engine really covers about 15% of the web, as many of you know. But when you combine them together, you actually have more information than individual one of them. You can do backlink analysis in Google and the Alta Vista. You can do group and personal profile search on Yahoo members. And actually, from Yahoo members, they actually create their own link. You can actually find out who they believe in. Very surprised, very surprised that with some young kids, they put on their website and their heroes are KKK, and this and white supremacists, and there's a link to the website. And you can take it out actually also from Yahoo. Message on bulletin board, web searching, Internet Archive. Other methods, the go to terrorism website, reports from US government, academic databases. That's about data collection. Analysis ranging from extraction keywords, phrases. This is really about entity extractions. Okay. And it's quite interesting that they add a little pattern. There's important people, important reading, the philosophy behind the particular readings that everyone will call it to, particular event. It's actually universal. I don't want to use the word ontology. It's a vocabulary that are convergent. They're all in it. With those ontologies, there's certain relationships, just like the quantum network I try to build. Over time, they become more mature, and then their group become more interconnected in some way. So we can build a dark web by creating lexicon, person name, special jargon, slogans, and expressions, and key trends in terrorism. And you can create the outlink, in-link from looking at the web pages. So you can calculate social network, and you can map, provide visualization. Some of the visualization is showing you can see the temporal dimension as well. And so let me just stop here, but this is show you sort of a diagram how we try to get from different sources and go through the different techniques such that they get filled into the 3 different databases that we're populating, such that they become resources that people can do research. Again, my goal is really to make it a science. It's an ad hoc research or ad hoc deployment. I think this problem is very serious, and just from sniper investigation to September 11, this whole range of problems you have to deal with. But you really have to carefully have a set of research coming from language processing, linguistic, to data mining, to algorithm, to visualization, to human-computer interaction. And then talk about policy issues. There could be just entire talk about privacy, security, confidentiality issue. Those data are very sensitive. How do you make sure that it doesn't get used for other purposes? Even though it's terrorism, these are open source. But I definitely don't want them to use it, right? But I want good guys to use it for good purposes, and I want to have researchers to use it. And I've been deliberately trying to avoid touching security data with all my abilities. So actually, we actually work with CIA and they say, but at times they send people over, we train them, off you go, how to use it, don't care, don't tell me. But my lab, everything we can to not touch any, I'm a US citizen, but I don't want to touch any security. I don't want to get security clearance, but I'll do generic research. But I think it's interesting, come here, we take what we can do, and we take it to do whatever good purpose we can do, but we don't want to get involved in that. So, all right, we can start here.
So, any questions?
You noted something which pointed out a difference between the kind of work that people in law enforcement do and the kind of work that people normally do with information retrieval on the web, such as you referred to looking through all the search results that you would get from a search engine such as Google, which is something people don't normally do, but obviously cops have to chase down all their leads. Is there another difference in that you don't seem to, for instance, use probabilistic methods in your data mining? In other words, if you're looking at deception detection,
Yeah.
you give probabilities for a particular name being an alias of another, or when you're mapping out these social networks, do you do some kind of smoothing so that it's not impossible for these people to net?
In some of the research, we actually do that, but let me just show you the progression that we went through. Our initial concept space actually have academically, they're all based on probabilistic weighting because of frequency and weighting that can apply. But I think some of the probabilistic results need to be re-engineered so that they understand. So our first version of the concept space, this guy and this other big guys, we normalize it. So this is highest 100% and then 80%. And then they look at that and think, what is the percentage? Should I believe in 75% or should I believe in 25%? It's really the interpretation of the percentage. Some confuse it. And the second thing is that they actually say, this is really not percentage. When I see they occur 4 times together, this is 100%, I know they know each other. I will treat it as the same category. Whether they occur 25 versus 200, these are all bad guys and they know each other. And just the activity doesn't tell you more. So initially, all the algorithms actually have a probabilistic. We can play all the math we can. But when we present it, we have to carefully withhold the information. In the current concept space that are using Boston is all probability, they are all removed. We only care that this appears in this number case and this appears in this number case. You do the judgments. Okay. But things like, I think you're correct, like deception detection, and they have different degree. When you look at the data, you can do a basic network. Actually, other research we use a lot of basic network as a basis to find out their prior probability, and now looking at data, what's their degree of association. We do some of those, but the deception, I think we can put that. Social network, there are actually a probabilistic link behind it, which we didn't show. So it obviously exists. But increasingly, the one that we use most probabilistic information is in the genomic research. That's actually used a lot more. Microarray, and then this one affecting the other one, was the bigger probability. But the point I'm trying to make is that we can use a lot of good statistical representation as the online algorithm. But when you get into the next level of trying to put it in the actual field of letting users use it, sometimes we have to be careful. What do we mean? The research, I try to explain to them 10,000 times. And these are smart cars. Or just keep on throwing them out and say, all right, wipe out whole thing. Oh, they understand. Oh, this is going to time. I don't care. So don't care about probabilistic. Just give me something that I can.
So I think this is a question related to data. One thing that I take away from this talk is that you've assembled an enormous amount of information. So there's lots of data, and people would like to be able to either reconstruct the data that they don't have, or to make decisions from these data. So when I see a big collection of data like this and real problems attached to it, I think of machine learning, which goes beyond association rules. And I can I can list a number of things that come to mind when looking at these. So you don't just want to draw a line maybe between two people and it's thicker if their association is greater. What you'd really like to know is it worth breaking down this person's door? Because based on their associations with various other people, not just the strength, but the type of associations,
Sure.
they're likely to have they're likely to have contraband in their apartment, for example. You might like to know, at a given location, is it worth stationing an officer there to keep watch? Or if there's a particular person on a particular corner, how long should you watch them for? This kind of thing. In the case, the classification problems are particularly clear in the case of what you call the dark web. So this is a relatively straightforward natural language processing problem which has been studied by a number of people in the last few years. Not for this problem, but very similar problems. So you'd like to be able to, given a sample of good websites and bad websites, you'd like to be able to classify discover and classify additional websites by bootstrapping keywords and phrases that might be indicative.
Yeah, let me just make comments about your first observation about once you do the clustering classification, what do you do with that? In this community, you can do a lot of analysis, you're going to find a lot of interesting pattern, a lot of interesting network, but the cops, all those analysts, they're typically doing, so in my mind, two ways. It's not like commercial application that you look for opportunity, they're all stranded in resources. So the first way is, when your boss wants you to check on this guy, there's an incident happened. So find everything about this guy and what that group is doing recently, you try to pay attention to them. So very direct order. And the second type is sort of more resource allocation. If you do a global picture analysis and I see a trend now, and so there's a big class of things emerging, I don't think it's all dying, there's no activity, just like looking at it that way. If you see KKK is increasing or Animal Liberation Front is decreasing, then you can say, and you put more resources. So typically that's what I see in this community, way of using the analysis classification results. But I agree with you, this is actually, just use a combination of techniques that people have developed. But what we're trying to do is really more carefully, I don't want to overuse the word framework of methodology, but we're trying to use a lot of existing collection tool, analysis tool that we think may be appropriate for this application domain, and hope we can learn from that process.
You talk a lot about the Tucson Police Department. Now, does the Tucson Police Department actually have your system, or is it just expansion? Are they using it, and if they are using it, is the Tucson Police Department more successful than some other police department which is not using it?
They are entirely relying on the system.
They are entirely
relying on a coupling system. If we take coupling away from them, the whole department falls apart. We replace the old system. The old system is gone. The same thing in Ann Arbor, Michigan. The same thing in Huntsville, Des Moines, Iowa is happening right now in Montgomery in Boston. This is not a toy system, and this is not a nice toy used by a few analysts. In Tucson, 1,500 officers, everyone is using this, and they're trying to use it for wireless and field reporting and so on. So this has become their bread and butter. In the past, when we do the research, an interesting sociology study or story, that the first 2 years we were convinced and value and so on. We showed them the prototype and so on, and when we have to get their feedback and so on, we have to drag them, we have to bribe them to come and give us feedback. After 2 years and do a lot of field studies and create deployment, and they're early adopter and they're the people who are more resistant. But then after 2 years, they have to bribe us to give them early version. So we actually take this group of 25 people, and then their other friends of them, they just install themselves. We only have 22 licenses, but then there are 30 installations. People just get it and install it themselves, and even old car, fat fingers, a black broken, just punch his name, can you find it? Bang, 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 and there you are. And that's the only way we can convince them that there's a value. So this is connect, but I think you hit a good point that this is actually a pyramid. Connect is used by almost everyone. Detect, so if you look at Tucson, Connect is used by 1,000 people, almost everyone. Detect is used by 200, detective. Officer doesn't have that much time to do the triangulation and find out other association at all. But detectives or crime analysts can do that. When you start to get into agent and alert, these are people who are working on cases that are urgent. Maybe 100 people, 150 people. When you start to do social network analysis, not only gang unit and narcotic unit. So there's a sort of a pyramid effect that when technique is more specific, they're more powerful, but at the same time, they're touching less number of people. Other people still have a lot of things they have to do. Yes, comment?
Yeah, I have a question. I can understand how police uses the connect portion of the program software. I was just wondering if you can expand a little bit on how they use the detect portion, because I think there are some issues that are, even though you can do all kinds of analysis on the data, there are certain legal requirements on how you can use those data. For example, you can't break into people's house just because there's some links that show up on the screen. There's some probable cause and stuff like that that you have to follow. So I was wondering,
We try to avoid that
how
problem.
you can-
We'll just give you a system. You still have to follow your standard practice and guidelines and so on. It's just one system replaces another
So
system.
so I was curious to know how the police.
But
handle
there's a
that.
big issues about training and about knowing what you see is what, especially for young cops. The computer is telling me that those two guys will occur and give 100% probability. That guy has to be bad, so let me get a warrant and bust him. For some old cops actually, that's also one of the warning that they tell us. And the detective know you're looking at investigative clues. It's a likelihood, and you have to use your judgment and talk to people on the street. But the young cops, they'll take that and run away and just bust people out. It's very powerful, too powerful to some extent. And sometimes they can do a very partial clue. Like Shorty did it, and Shorty was always in that block, and Shorty has a tattoo on the neck, and you do the search. If someone seems to know, you just go out and get a warrant and bust the guy.
Because this issue actually, like
Do you actually have a taxi at 12:40, as you told me, or
What's that?
you said to me that you have a taxi waiting for you at 12:40.
Yes,
So
12:40.
should we watch out for
Yeah,
that?
watch out at 12:40, 45. I don't think, I gave a big tip this morning, so I think we'll have to wait for 5 minutes more.
Okay, fine.
12:45, but I believe at 12:40 for sure to
Yeah,
watch it.
okay.
Yes,
Yes, I just wanted to ask about the legacy data,
Yes.
because we have a small project with police, and we find they don't have very much
Mhm.
electronically stored.
Yeah.
Are they starting to store the kind of information you need to use for detect and connect, or
Yes.
do you find that they have
yeah,
that?
basically, actually, I've talked to a lot of agencies. You'll be surprised from, the worst one I've ever seen is Washington DC. Sorry. Behind closed door. But they're using all IP mainframes and so on. But most agencies in US, they're actually sort of the older generation, really old, using file folders and they don't do anything about it. Very small percentage actually. Most of them has at least the second type of system, which is mainframe, the big mainframe model, DC police like that. Okay.
Are they manually entering
Oh, yeah,
whose
yeah, yeah.
friends
They
are
actually-
who and
The
what
process
kind
is
of
as
car
follows.
they
They go to the incident, a citizen complaint and so on. And so your interaction, my dog is barking at night and my neighbor's dog is barking, so then they have to fill out the report form.
drive?
And then once they get back, some agencies do it differently. Some agencies will let the cops enter them themselves, they don't train them in typing. But some agencies have an army of data entry clerk. Tucson, all the police department office enter themselves. Phoenix, there are 30 or 40 people in the data entry division, and they train them to write the block words in blocks, and then the people enter that. Tucson is in the process of doing the automated field reporting, so they just have to report themselves. They don't do that. And there's some agencies even braver, and I work with some agents trying to use voice recognition. But they hate it. It's so hard, and then they have to wait the mind, and they have to get trained by the mind to recognize it, and almost everyone give up on that. Automated field reporting, they all did. So the past 10 years, I'll say most of the agencies, I'll say 80-90%, they all have their data stored already somewhere, but they're all different kinds of, different generation systems, from mainframe to workstations, Unix kind of
But I meant
boxes.
the content. They store the kind of information
By law, they
that
have
you
to store
need
the content.
generally
Yeah.
for using.
By law, they have to do that. By law, any interaction, they have to write an incident report. Incident report is stored somewhere, and it's not intelligent information, by the
But
way.
in England, it's almost always on paper still. They actually don't get it entered, but we find here they do.
And actually, I've been to Shanghai, and actually Shanghai is interesting. Shanghai is the biggest department that I've ever seen. They have about 18 million people, about 30,000 cars. And this is the only police department that I saw that had a supercomputer. They have SP2. It's a supercomputer in the back end because of the population. But we're a little hesitant to show them the entire coupling, but I don't want it to be on the newspaper front page and say, funding coupling provided by NIJ DOJ has been used by Shanghai police to track Falun Gong, or that's very bad. They may be doing that for other crimes, but just do that one time was good. So we're very careful, but they're monitoring this kind of thing very closely. And we'll give them technical advice on what I think can be done in interoperability. But their problem is less severe. US problem is that there's so many different generations, so the conversion into form is very difficult. They don't have old generation. They have papers, or going to the jump to generation ahead. And they're just beginning.
You said you're not using the narrative descriptions from the reports. Is there information in those that you would like to use?
Yeah. We actually worked on narrative for 2 years. In Connect and Detect, we didn't use narrative at all. 2 years ago, we did entity extraction on narrative report, looking at people's name. People's name is easy. You can get 80-90% accuracy. Property is difficult because there are different properties that may involve for cameras or almost any objects. Drug is very, very easy. I mean, what kind of drug that involve? Weapons is easy. Vehicle is easy. So for some of the more standard type that most entity extraction people have looked at, that's easy. But the more difficult challenge is not the extraction. Is what pattern do you see from the narrative? It seems like the only thing that we can get out is certain crime that have MO, entries or the patterns of entry that are more revealed. This kind of, in this report you will say that this person goes through the window and use a crowbar to open the window and get in there, and then go to the restroom a few times and come out and turn the faucet on and go out. I think that's one of the movies that the thief does that. The patterns of behavior. Other than MO, we couldn't dig out a lot of good information from the narrative. Almost the most important one are revealed in structure fields. Location, people, addresses, and so on. So we put it off for 2 years, so we may get it back again. But they would like to retrieve the narrative, but we still don't know how to analyze the narrative. So I didn't emphasize the narrative in this talk.
One thing is not clear is that is the data warehouse shared between departments or is it just within the single police department?
The data warehouse is shared across the universe. Okay. Yet in agree. It's entirely policy issue. Just look at the example of Tucson. In Tucson, each division, they can all share information now. But Tucson is sharing information with Phoenix. Okay. Now in the process of sharing information with San Diego using VPN, virtual private network. So now Boston is also on now. So if they want to share, all they have to do is say, I turn my switch on, you take the switch on, just in your IP address. Find a vendor doing VPN, just using the public net. Hey, we're on. You want to connect to Shanghai, they will all agree that we want to share all policy issues. And this new initiative that we're doing called Border Safe, border safety, is linking the southwestern border state. But the brave thing that we really want to do is linking US agency to the other side of the border. And that opened a huge can of worms because of the trust issue, the different practice they adopt, and whether they'll misuse the data or not. The Tucson go to Nogales into Mexico, and San Diego goes to Tijuana in Mexico. So their police are actually working on many similar cases, caught them getting together. But this trust issue is the most difficult one. Actually, I don't know enough about the Mexico databases, agents databases. I actually never visit them. But I suspect some of them will be more advanced. And right now, DHS seems to have interest in funding some of those agencies so that they can begin sharing information. So I suspect this will be more limited. I think especially that the agency from their side with more limited access to their data. And probably they will impose the same thing, not as freely open sharing as in the US.
I think we're all